exciting. We are really glad and happy that so many people came over to talk about documentation. It's a hard stuff. We know that. And we would like to share some experience with you. Okay, technical. Obviously, if you have any questions, there is a Slido thing running here, and we'll be covering that. That's why we have 2 laptops. One of us will be handling questions. So if you have any questions, just shoot it. Slido. As we will be talking about documentation, we believe that every documentation should have something like too long, didn't read. So what we'll be covering here will be a documentation that should be just in time, that should appear promptly, right time, in the right place where you expect it, with right information. This is something that we'll be covering. So if you were thinking about having a look into other talk, this is too long, didn't read, you can go. But you can also stay, and we'll get into the details. For us, working with documentation is very often like with this example. This is one rabbit. And if somebody comes over and give you one more rabbit, then you have 1 + 1 = 2. You have 2 rabbits. Understanding these basic principles of arithmetics, we can go further and use it for more complex example, and let's solve this equation. And this is pretty much how very often it works with documentation. We come over some very basic examples, and then based on that, we try to build up, making more complicated stuff. And you can say, well, that's arithmetic. That's not how it works in IT. That's not how it works in programming. In fact, it does. Because if you come over to any Java thing, like this stream API, not talking whether it's monad or not monad, that's not the case in here. You have a map function and a flat map function. And once you understand how it works, then you have an optional class which takes exactly the same principle. You don't have to understand another one. And then you go to completable future and completion stage. That, well, not. It builds on the same premise, but it's called differently. And it brings confusion, and it brings misunderstanding. And that's something we would like to cover, how we can avoid this situation.
Okay, so I'm Zbyszko. I work at Dynatrace. I'm also one of the Juke organizers. I wanted to place a picture there, but decided since I'm here, here I am, that's me.
My name is Jakub, and I'm a software engineer, and I work remotely. That's why my Instagram is full of cats. And we'll try to get you through the documentation journey. Zbyszko, you recently changed a project, and yes, how it worked with documentation for you?
Okay, so there was a situation I wanted to find out something about domain. Like, I entered something new, so I wanted to know what are the strengths of the domain, what it actually does, what is the roadmap, and so on. And it turned out that only place I could actually access something like this was a sales pitch presentation. So basically, I was pointed towards a PowerPoint file to see what products does actually look like. Once I actually got to know the product, got to know its strengths, its architecture, and so on, I wanted to code, of course, something in this, since I'm a programmer and that's what they pay me for. But then the most fun game started, game of who has the knowledge. It's always like you find some person that did some documentation like 5 years ago. It's obviously outdated. So you find this person in the company. If you're lucky, he still works there. He points you to the next person who took over after him, and then after him, and so on and so on. And then you actually find out what the thing you wanted to know. So what's your experience on this?
Well, it's pretty much the same. I found a recent Slack conversation that pretty much outlines how documentation is covered in many organizations. So we had that README, and there was some information in the README, though it was great, but misleading, and it didn't cover on many cases, and yeah, it was simply wrong. So, do we need documentation at all?
Yes. So basically, the experience I described you, Cobalt described you, I think it's experience that many of us had, like documentation that is misleading, missing, not enough. So does making documentation actually is worth the effort? Like, is actually useful for anybody? We think it may be, but there are some problems that we have to face before we start. So basically, we have to answer a few questions, and that's what we'll be doing during this presentation. The one of those is, are we solving the problem with the right way? Or are we documenting in the places where somebody would look for this place? Okay.
So, to answer the question, we start to think, what are we documenting? So one thing we would like to document is the business domain. We would like to cover what business we are running it, what are the constraints, where we are making money. And then a different concept is the high-level architecture. We would like to understand why are we using Oracle database versus MySQL database, or why are we using Cassandra, not other non-SQL store, and why are we using Kafka, not RabbitMQ, or the other way around? So high-level architecture. And then we got to low-level design decisions. Why are we using this types, or why are we using this particular frameworks or libraries? And we see that those things are orthogonal. They go in different directions. They are intended to be read in different moments of your project by different people, and we should keep them separately. We should really think and we should distinguish what we are documenting versus how we would like to document that.
There is one thing we want all of you to have in mind while listening to us and doing documentation later on is that all those three layers we described have a different tempo of change. We call it decision sustainability pyramid. It's patent pending. Basically, what this means is that business and domain changes slowly, like once a year, once a quarter, once a week if you're in a startup. Architecture changes too, changes faster because not only the business decision changes, but also technological reasons may force you to change the architecture without changing the domain. Of course, code itself, the low-level design we describe here, is something that changes every day. Every time you commit something, push to master, this is when things change, so they change quite quickly.
So if you would like to see what tools and what means we can use to describe things on different levels, we'll drill down that now. So if we start with the business and domain, how can we capture what are we really doing business-wise? And I would like to share with you some experience of a flexible workshop format, collaborative exploration of complex business domains, beyond silos and specification boundaries, also known as EventStorming. Who came across and tried EventStorming already? Okay, few person. That's good, because it means that next few slides will be meaningful to you if you haven't done it. So the idea of EventStorming is to grab multiple people into a single room. People not only from technology, but also from business, from sales, from all different stakeholders around the product, and do a facilitated workshop to better understand what the project looks like and what the project is really doing, or what the product is really doing. So we start with a white canvas. It should be big, like huge. And what we'll be doing, we'll be posting post-it notes with domain events. So an orange node is a domain event, is a fact in the past that we would like to capture, like the payment has been processed, or the item has been added to a cart. And as we play around, we add those nodes, and we add more of them, and more of them, and even more of them. It's done by both IT, by sales, by everybody who has any idea of the product. And as we go forward, there start appearing some different colors and some different nodes. On one hand, we have events that are not very clear, that people start to debate about, like whether these two should come in a very particular order, or whether this is extremely important, because if we do not comply to that, we'll be exposed to multi-million-dollar penalties or whatever else. And then we flag it as a hotspot, as something that requires additional understanding and additional discussion. And on the other hand, some concepts start emerging. Some vocabulary, some common concepts start to be discussed, and it's good to capture it as a definition. If there is an investment, it's an amount actually put in a specific loan. And as we progress, things start to get ordered. As a part of a workshop, we start to define a starting event and a finishing event, start to order things in a more of a time lapse. And as we go forward, the cards get structured and structured and structured. As you can see, this is a time lapse for a real EventStorming session. So as you see, as we progress, cards start to move around and get some structures. We go forward, more cards appear, more different colors, until we get to a point that we start to have some additional cards. We get things clustered around. We start to see that certain events are working together. They are like connected to each other, and there are some additional things that happen to trigger that event. So we call them policies. Sometimes it's automated, sometimes somebody has to click it. We just capture it and put it onto the wall as well. As we go, we got to a point that we can start involving the users. We have certain events that require a user action. Somebody has to click something. An end user has to commit to certain action. We also put it here. The whole session, the high-level picture of EventStorming, the high-level overview, it's usually doable within a day. It's like 6-hour workshop split into multiple sessions, and within the 6 hours, we can get a fairly decent overview of a system, which I believe is amazing, because if you get to a fairly complex domain, having it captured in a high level within 6 hours is quite an achievement. And as you have everybody, all the stakeholders in the session, from sales to product owners to the engineering team, you can very quickly onboard people with the domain. You can get them initially understand what's going on without having a need to translate that from business to IT people. It just collaboratively explore the domain. And accidentally also, as those things cluster together, you can start seeing a certain boundaries, component boundaries or service boundaries that may later help you with better structuring the system. But first and foremost, it gives you a decent overview of a language that we are doing and we are using in this project.
Yes, exactly. This is very important for the things we are discussing right now. Right? It's basically documentation. Consider this example. We have a domain where there's a product. But in some places, product is called item, in sales pitches and managerial stuff. An API is called inventory element. And of course, in the code, it's called every single way imaginable. Why is this a problem? This is basically a problem because even though we may think those things are the same, they may not be. Even if they are, we may not understand each other, which means that we won't be able to document things properly, we won't be able to understand them, and basically we won't get this common understanding between business and developers. Basically, it looks like this. This is from Michał Bartyzow's book, by the way. PO may have some understanding of things like add series, add an episode, paid nor paid, and this can understand it differently. So imagine that we have a PO understands something like my library, which we understand as a movies list, but if we want to have something different than movies, this won't actually fit. And there can be like things like add FLV file, which for us is the same as add an episode, which really isn't. the process that Kuba described basically allows you to produce a thing called ubiquitous language. It's something taken from domain-driven design. Basically, what you have here is a documentation of not only dictionary that you use, the things I just described, but also the processes. So you have a common understanding of the processes written down somewhere in a plain, simple English or Polish sentences. And this is important because if we want to understand the domain, we have to have this. And if we want to make our lives easier to of documenting architecture, this is very useful. So let's get to the architecture. First of all, let's ask ourselves a question: what is architecture? Of course, you will find like many definitions of this. We took the one we think is convenient for us, of course. It's basically the answer to the question, how do you solve your business goals with technology? So you can see that having this processes described by a ubiquitous language is quite helpful here. One thing that people are often missing when documenting architecture is that they focus on the how the system works, what the database we use, what queues and so on, without actually having the information why the decision was made. So in the future, we are bound to make the same mistakes. We don't know how things were made, and we don't know the constraints of the system because nobody ever written down why the decision was made. But there's an answer for this.
What we try to do, we don't want to design up front. We don't want to do the huge description, blueprint design, and so on and so forth. We would like to have the architecture emerge and have documented what's emerged. So capture the changes and the decisions that we've made. Because architecture is pretty much decisions. Decisions that we made throughout the project. And there is a very good tool which tries to capture that, which is called Architecture Decision Records. And it's well described, it's well defined, and it's kind of a convention how we can tackle that. Architecture Decision Records, which is here an example, capture multiple things. There is a title of a decision, and this is taken from an open source web project in Clojure, where they did all the decision as the ADRs. There's a title. We would like to have a data abstraction model. That's an example. So this decision needs context, needs some understanding. Why are we making this decision? Why are we thinking about it anyway? So there needs to be a way for the modules to speak in a common language for data manipulation and persistence. That gives you a context. Why have you thought about it? Because worst thing about many architecture decisions in your projects might be that you see somebody did something with a clear intention, but there is no way to understand what was the intention. You see that it is not normal that somebody is using reentrant logs in your code. There must have been the reason, but you can't find the reason. You just see the log, which is not enough. And then there is a decision. So we would like to provide a lightweight model for data abstraction and persistence oriented around entry attributes modes. That's the decision, and it's taken. It has a status, and then it has consequences. As we made this decision, there are certain consequences, like users and modules can define the shape and structure of their domain. The thing is, it captures another thing which is very important for the architecture, is that you've made a decision, you've seen the consequences, and fast forward half a year, somebody comes over and says, you know, but using RabbitMQ here is really shitty. We should have done it. We should have never done it. Or the other way around, using Google Web Toolkit for your UI is just bad. You shouldn't do that. Now in 2018 or 2019. But then, as you've made that decision 3 or 4 years ago, the context was different and the consequences were different. And having that in your project, you can pull it out from your repository and say, yes, but in 2016, when we made this decision, that was the context and that was perfectly valid decision. We can reevaluate, we can give it a thought, but that was our context back in time, which really helps you understand and move things forward, because you avoid a situation when somebody comes over and says and question a decision, and you say like, yes, we've talked about it, but I don't remember what was the outcome. What it gives you kind of an event-sourced architecture. You don't have a final state, you have intermediate goals, and you have to snapshot your end state. But on the other hand, it's immutable. Every decision record is put somewhere there out to wiki or Git. It is there even if it's not valid anymore, and you can trace it back and see what was the decision. But the decision itself is not everything, because equally important to what the decision was also how it was made.
Yes, and for this purpose, we would like to recommend you a tool called Daisy. Daisy is basically a way of doing the decision-making process asynchronously through some means like the wiki pages and so on. It's actually an acronym. It stands for the role that you have inside of this process. Basically, it's a driver. Driver is a person, mostly you, that drives the decision-making process. Basically, handles the other roles of the process, puts the context, the one that you later have in the ADR, there's some proposals, some constraints, and so on, and puts some kind of date when the decision should be made, usually a few days from the moment that the AC document was created. A few days is enough. There are very rarely decisions in IT that need to be made right now, so that's okay. Approver is a person that, well, has this big stamp that can say approved, that we can do this, and so on. It should be one person. So if there are more people, there may be different opinions. But basically, the best thing to do here is to have a single person that can check the checkbox, and we can do the thing that we described there. Contributors are the people that will be implementing the decision, that provided the options, and so on. So basically, for example, your team. And informed are the people that will be affected by the decision that was made. In practice, the main part of a Daisy looks something like this. We have some table with some options rolled out with pros and cons of this, risk, and so on. When we will be doing this, I will highly recommend to keep this part here, the do nothing option. Like, there's often cases when the right decision is not to make any decision at all. So this is about architecture, right? So this is how we capture something that is moving quite fast, but like I said in the beginning, there are things that move faster, which is called low-level design. It's a code, it's basically the things we do every day. So I have a few problems with documenting the code or the way the code works. First of all, the wiki pages that somebody with good intentions, of course, try to document something, why code works the way it does, and so on. And it's like mostly this something that he stops doing after a month or something. The enthusiasm begins to fade, and we are left with dozens and upon dozens of wiki pages that make no sense right now. Of course, the other one is quite related. It's a tribal knowledge. So those are the things that somebody in the organization knows. Like I call them shamans, basically the people who are in the know. Architects, archaeologists, call them whatever you will. But those are the people who you go, pray for some knowledge, and ask and you shall receive. And once we have all of this, another thing is that is confusing code design. So basically, this is something we should all know, the clean code and so on. Some principles to follow that will allow us to read the code without actually having the need for the documentation itself. And this is basically something we would like to recommend. Like in the beginning, we told you that the tempo of the change is quite fast here because we are basically committing code every day. So this means that documenting these things is very, very hard. Basically, from my perspective, almost impossible. I wouldn't recommend using comments, for example, as a way of documenting your code, only if you want to document APIs of your libraries or modules, or for example, there's something that is not obvious and it's very hard to describe in the code. For example, we have to put 2 here because this system doesn't operate the way that 1 is a viable option. So something that is not obvious from the code, this is what we should document. But as Uncle Bob says, always feel that if you're commenting something in the code, this is basically a failure. There are other principles we would like to recommend that would make code more readable and basically self-documenting. First one is discoverability. It's basically having those beautiful single points of entries with fluent APIs that just flow from A to Z. This is an example of a library called Jog. It's basically a way of writing SQL queries inside of your Java code. And if you know SQL, you'll be able to use this. No documentation, no additional documentation needed. There's another thing that comes from having modern tools like IDEs. There's a term that UX designers know for a long time. It's called recognition and recall. To put it in perspective, recognition is when you're walking down the street and you meet the person that you know he's from your high school, you know the face, you start talking, and then you spend all of this discussion with him trying to remember what was his name. Recognition is the way when you see his face, and recall is this process of trying to remember his name. The same works here. So basically, recognition is you know there's a method that does something like this. You don't know the specifics. You don't know the parameters. You don't even may know the full name. But IDEs will help you. You can easily see something like this when you just write down something, see parameters, and you move forward. So designing the APIs this way makes them easy to use. Types help. You don't have to have statically typed language for this, but having types makes things much easier. The common problem with our APIs is that they are using types that are quite generic. So the second example on this page is, of course, longer, but I think, but that may be subjective, it's quite easy it's easier to read and easier to understand. This doesn't have to be a string. This is an example from string that also uses ends and booleans. You won't be able to understand what is this without actually going through the code or reading some documentation, or basically like every sane person going to Stack Overflow. Other advice I would like to give you is to keep things simple. So I know that your awesome API can handle like 15 different parameters of ways of doing things, but the person who starts using this will not know this and will not understand how this works. So you can always have other options available, but try to start with some sane defaults for this, so you won't scare off the potential users of your library or module even before they start using this. Of course, this is a complicated process. I don't remember who said this, but simplicity is not simple, right? It's something that you have to predict what are the actual defaults, what are the ways the users will use your library. You will probably get it wrong a few times, but it's important to have those few additional steps in the beginning to think about what defaults should be. And that another thing that is important is to have consistent APIs. The example was already provided to you. Like, you have stream and optional which are consistent with each other, but completion stage, not so much.
And there was already a question on Slido. So should we comment our code, as Duško said? Rather not. If you can express yourself in types, in naming, that's far, far better. Because then you can make things consistent, as consistency is better. And consistency, in fact, is the king. Because then you can take it to the whole next level. Still being a little bit between the code and the architecture. If you stay consistent, you can run and play with the conventions, which is a really powerful tool. Because if you are running an ACME corporation, and you're building a service called registration, then it's good when your repository is GitLab ACME/registration. We keep the conventions. Because then people having any problems with the registration know where to find it. And we can take it further. because then the production deployment can run on registration.acme.cloud 8080. We know where to find it. We know where to look it up. And if we go further, then the Swagger can be on the registration Acme Cloud version 2 API docs. And we always know where to look up the endpoints. I don't say always use Swagger. It can be whatever tool. It just lives on the very particular URL. And we can go further. As our application works on production, then the traces can go zipkin service called registration. We know where to find it. We have some issues, we know where to go. And the Grafana, the metrics, are again in a very particular place. If we use Grafana, that's this endpoint. That's where we go to. We can collect them, and we just can use them and play whatever service we are building. And then if it has a README, which contains a context section, we can scrap it. And if all the README files, by convention, has this section, we always know what the service is doing. And we can go forward and forward and forward. We can derive the upstream services from traces and from circuit breakers. That if we are calling another service, we know whether it's alive or not based on the activity. And the activity is related to a very particular name of a service. And then we get recurrent. And so on and so forth. Because what we are dealing here is we are talking about the user experience of a documentation. And the user experience is not only about end users. It's about your fellow programmers who are working with you and who are struggling with many, many, many things. And if we build on this assumption that documentation is a part of the developer experience, we can try to apply some usability things to our documentation. If you go to any usability website or whatever, then you see, without getting too much into the details, that usability is all about learnability, about efficiency, memorability, errors, and satisfaction. And we can work on each and every part of the documentation based on those 5 premises. We can ask, is it LEMES? So if we went through EventStorming and the business domain, we were focusing on, in my opinion, on user satisfaction, because based on that, they know the product that they have been building, and they know the context that they are in. And it was about learnability, how easy they could have accomplished their task based on the domain knowledge that they have. But then if we go from the business to high-level architecture, and we go through decision and records, it's about efficiency and memorability. It's about efficiency not having to ask the same questions over and over again. Because those decisions are captured, and they are somewhere in your Git repository or whatever. So whenever you think about writing a piece of documentation, just ask yourself, is it LEMES? And what people will benefit from, and where do I put it, and whether it's a right place and right tool and right context to put it. Thank you very much. If you would like to get further into this kind of concepts, we left some of the links that we are talking and mentioning about EventStorming, about decision records, and DAISY. So go and explore further how you can do it in the right way.
Any questions from the audience?
So if you have any questions, yeah, sure. Yes, we will share the presentation. We will share the presentation.
Where do you want it?
We will. Yes, we will tweet it with the GeeCON. I think it says somewhere, but we obviously haven't put the link in here because we are still not perfect with documenting.
Yeah, I was making changes while he was speaking. So.
Yes.
Any other questions? We have questions on Slido and new questions.
That's one of the problems with the documentation. If you keep things in different systems, then you not always catch up with.
So how would you suggest to specify class contract? Well, that's basically something that we want to do with inside of the code. So basically, for us, it's some interface with some Java doc or other tools to document this. And the important thing for us, make these entry points very small, so you don't have to document it very much, because there's, like, for example, one way of entering your API. So in this case, it's quite easy to document this. I don't know who asked the questions. I know that's the answer he or she was looking for. Okay.
Does it answer the question?
Does this answer the question? Yes, it does.
There was another question. Can you recommend some tools to easily create storage and access with search ideas for the project? There are multiple. There is a website called idea.github.io, I think, which is somewhere among those links as well. That covers multiple different tools. There is a project called ADR Tools by Nat Price, which is a CLI comment with templates that allows you to quickly type in stuff and then have those ADRs prepared. Where to store them? I store them in GitHub. And how to efficiently search them? I use my IDE. So if I have them in GitHub together with my project, I usually use Ctrl+Shift+F. And that's a very good search tool for the context of my project. And that works for me. I won't say that it will work for everybody, but the simplest, the better, I suppose. So if you even, there's this ADR tool, which is a CLI tool, which is quite efficient and quite good, which I would recommend for the capturing the decision records.
Okay, so there were more questions, but they seem to have disappeared.
They disappeared?
Yeah, they disappeared. One other thing, as for tools, if it comes to DayZ, since it's the Atlassian thing, there's of course a template in Confluence if that's something that you're using. So you can use this. And that's all for the
There's also about chart diagrams and any other images.
Right.
That's again my personal preference. I try to avoid binary formats to store documentation. It's not searchable. So if it goes to diagrams, there are things like plant.uml or data, which is pretty much an ASCII art thing. The diagrams are not the most beautiful, by no means, but they are text-based and very easily searchable. So again, you search for your ID, and it just appears there. One of the projects that is an umbrella for all of those is ASCII Doctor, which I personally use, and it has handlers for all these fancy tools about documentation. But even if you start with Markdown or just text files, you will notice that it's far easier to work with that compared to any Word document or a wiki, because it's text-based, it's very easy diffable, you can change and spot differences, and you can keep it together with your code. So it makes things much easier.
So the last question is something that I think we answered on the presentation, but I want to reiterate this. Is writing comments within the code should or could be considered as just enough documentation that we need? I think it's much more than we need. Basically, like I said, comments is something. Well, if you mean the API in Javadoc, for example, from some API, that's fine. But comment in the code should never happen. Basically, write your methods like your code, like it's written in English. Write it such a way that somebody reads it and can understand from the beginning what does it do. And like I said, use comments only if something is not really describable within the code. For example, some external conditions or constraints that limit your product. I think that was the last question.
Unless there are no more questions. Thank you very much. There's nothing else that can stop you from lunch at the moment. Thank you.
Thank you.